Actually two parent graphs that you need to know. And they are the square root, and then behind that other screen is the cube root. Okay, so let's do y equals the square root of x. Just super simple. In my examples, I'm going to be putting those transformations back in. Right, the square root of x minus 3, the 2 times the square root of x plus 5, right? So we're going to be moving that shape around the screen. Okay. All right, if you put in some values for x, and notice, look at the x's I chose. Usually I do like -2, -1, 0, 1, and 2. Why do you think I chose different numbers like 4 and 9? Because I can do square roots of those, so they're going to come out to be nice numbers. Could I put 2 in my table? Sure, I would just get a decimal answer out. So that's fine if you want to put those in. But these I'll actually be able to do pretty quick. Okay, what is the square root of -4? 2 times 2 is -4?
2i.
It's imaginary, isn't it? Will you be able to plot that on the coordinate plane? No. So square root of -4 produces no solution. So I'm just going to put like an X. If you type it into your calculators right now, it's going to tell you error. Okay. So no answer for square root of -4. What about the square root of -1? No answer, right? So there's no answer. There's going to be no point at x equals -4, at x equals -1.
Why can't we do imaginary?
Where would you put 2i when you go left 4? If I go up 2, that's +2, real. If I go down 2, that's -2. So like we're graphing on this coordinate plane. This is the x-axis and this is the y-axis. And both axes are full of real numbers only. So like we don't have a place for 2i. Can you eventually, later on, graph imaginary numbers? Yeah, but it's in an imaginary plane. So we're not there. Okay, what about the square root of 0? Can you do the square root of 0? Yeah, it's 0, right? So now we can go in, we can do the square roots. The square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. Okay, so I'm just plugging those numbers in and doing square roots. Now I'm going to plot my points that work. The first one that works is 0, 0. Anything less than 0 is negative, and I can't take square roots of negative numbers. If you're on your phones, you should be taking notes. Just FYI. And so 0, 0 is the first one that works. So in this graph, it's kind of interesting. We didn't have this with the V shape or the U shape. It has a starting point. 1, 1, 4, 2 would be going right 4 and up 2. And then 9, 3, I would go right 9, so I'm a little bit off, and up 3. Okay. This looks kind of like half of a parabola, sort of. Can you imagine that? Like if you were to turn around, it would look like that parabola, but it's on its side. That's something we're going to get to later in the chapter. It's called an inverse. Okay, so the square root of x is the inverse of x squared. So the graphs are related. They're reflected, okay, over a line y equals x. But you only get, when you do the square root of x, you only get one side because you can't do the square roots of negative numbers. So you just get that one arm of the parabola. Okay, take a mental snapshot. Remember this picture, right? If I ask you to graph any square roots in chapter 5, the shape of your graph must look something like this. It can be moved left and right. It can be moved up and down. I can vertically stretch it, or I can vertically shrink it, Okay, and we can do horizontal stretches and shrinks. Those are less common. I usually don't ask you to do those on quizzes and tests. Okay, but you can also horizontally stretch and shrink the graph. Okay, let's talk about domain and range. What kinds of x's work for this square root function? X's that I put into the function and get answers back out. Positives and 0. So we're going to say x's that are greater than or equal to 0. Think about that in terms of your graph. Here's x equals 0. It's the y-axis. Your graph only shows up on the right side of that.
This is like last time we did domain and range, where it'll be the same for every equation.
Unless I start moving it. So on the next slide, I'm going to talk about what if it gets shifted. Okay, but like, can you imagine if I move it right 3, then this starting point goes right 3, so now my domain is x is greater than or equal to 3 instead of 0, right? But you'll see the same thing. The square root graph always has that start point, so it always has a restricted domain.
So it's whatever your x intercept is.
No, I could move it right 3 and up 2. And then it's still, the first x that works is 3. Okay. What about range? Y's that are greater than or equal to 0. Okay. And again, Delaney, that one, like if I move it right 3 and up 2, now the first y that works is 2. So it's going to be, these two numbers that are in domain and range are going to be your like left, right, up, down shifts, your h and your k's. So you kind of know what numbers are going to be in the domain and range. Okay, let's do cube root of x. Notice I changed the numbers that I'm putting in for x in my table, right? And I'm choosing numbers for x because I'm thinking smarter, not harder. That when I put those numbers in, I'll actually be able to do cube roots. Right? So I'm thinking about perfect cubes that I know. 1, 8, 27, but I'm honestly not going to graph something 27 to the right, because that's a lot. So I just went from -8, -1, 0, 1, and 8. Okay, if I try to put in -8 for x and I do the cube root of -8, what happens? I get -2, right? Is there a number that multiplies by itself 3 times to be -8? Yeah, -2. I can take odd roots of negative numbers. -2 times -2 is 4, times -2 is -8. So -2 is my cube root. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. I'm going to skip cube root of 4 right now because I know how to do cube root of 8, so that's 2. And I just wanted to model, like, you can do numbers that don't work. So someone with a calculator, will you do a cube root? Remember, you have to type that 3. Type in a 3 and then do second.
1.5.
Should be a caret. What'd you get?
1.58.
1.58. Is that what you got? Did you get a cube root? Oh, you have to hit math, right? And then it should be on your list. See if you agree with that 1.58 for me.
Hold on, my
Yeah, it's worth it to maybe pull out your calculator to make sure you remember. Oh yeah, you can do that. Good. You can also do it hit math real fast. You have a cube root and then you have an x root. You can use that too. Okay, so now I'm going to plot those points. All right, -8, -2. So I'm going 2 to the left, or sorry, 8 to the left and 2 down. -1, -1, so 1 left, 1 down, 0, 0, 1, 1. I can put 4 and 1.5 on there, somewhere right there, right? And then I'm kind of like off my screen a little bit, but 8, 2 is way up over there. Okay. So now I connect the dots. Put an arrow on both sides because it's just going to keep going, right? Like I can do cube roots of all the negative numbers. And I can do cube roots of all the positive numbers. So I don't have the same problem that I had with square roots. Okay. Mental snapshot, take a little picture, memorize this shape. How are you going to describe it to yourself? You know how we talk about like V shapes, U shapes. What do you know about square roots and cube roots? I always say like the square root is like a little hill. It's over to the right, little hill. And then when I think about the cube root, I think about like a stretched out S shape. Okay, kind of like if I had an S and then I pulled on it, I would stretch it out, or like a snake. Okay, that's my cube root. You're going to have to practice drawing this just so that you get that nice like curve, right? It's not turning around, it's just kind of bending right there. And that's going to be the point right here that we're always going to be like when we do our H and our K's, we're going to be moving that point. So it's kind of like our vertex was for V shapes and U shapes. And then we know that the bend happens around that point. What would we say for domain? What kinds of X's can you put into cube root and get answers back out? Anything. So we'll say X equals all real numbers. And what about the range? What kind of Y's are you going to get? This side is always going lower, right? It takes it a while. It's kind of flat-ish, but it's always going down a little bit. And this side is always going up just a little bit. So are there any Y's that we won't hit? No, eventually we'll get to them all. It'll take us a really long time. Because if you think about it, like when we do the cube root of 1,000, so when we go 1,000 tick marks to the right, we're only going to be going up 10. So it takes it a long time, but really it would hit all real numbers. Okay, there's no number that's saying it like won't be. Okay, now that one's nice, like Delaney's question. If the domain is all real numbers for a cube root and the range is all real numbers for a cube root, it doesn't matter where I slide or move or stretch that thing, it's always going to be all real numbers. All real numbers all the time. Okay, so square root, you'll have to think about your H and K. Cube root will always be the same. Any questions on the parent graphs? Okay, remember, these are the two shapes. If I'm asking you to do square roots and cube roots, better be one of those shapes. Not a V shape, not a U shape, not a line. Okay, let's just review really quickly our transformations. Okay, I won't spend a lot of time on this. You got new parent graphs, but you got the same transformations. So what I'm really saying is like take that mental snapshot. Remember those parent graphs. Remember those points on those parent graphs. You just have to move and stretch them like we did back in chapter 2. So f of x minus h moves it left and right. Remember, if it looks like x minus h, it's going to the right. If it looks like x plus h, it's going to the left. So h looks like the opposite still. K is going to move your graph up and down. That's going to be a plus K and a minus K. And it does what it looks like, right? So if you see like a minus 1 in the back, it's going down 1. You see like a plus 5 somewhere outside of the radical, then it's going up 5. And then you might have something that's getting multiplied in your function. Okay? When it's multiplied on the outside, which is more likely what I'm going to be asking you, right? This is the vertical stretch or shrink. Okay? So A times Y is a vertical stretch if the absolute value of A is greater than 1, or a shrink if the absolute value of A is less than 1 but greater than 0. Notice in that rule I talk about having absolute values of A, so you're just looking at like the number value, not the positive or negative sign, like how far away it is from 0 to tell if it's a stretch or shrink. Because if you have a negative A, that's a reflection in the x-axis. So if you have a negative A right there, that's going to be a reflection. This should all be like, oh yeah, I remember this. This is chapter 2. Maybe it's been a while, so gotta go find that in my brain, but it's there. And then if you were ever to see an A that's inside the radical, so it's like right with the x, it'll be like underneath the cube root or underneath the square root, so like cube root of 2x. So it's not being multiplied in front of the cube root, it's being multiplied in front of the x. That's horizontal stretch and shrink. And remember, horizontal stretch and shrink, just like horizontal movements left and right, it's like the opposite of what you think it is. So it's a horizontal stretch if the number being multiplied by your x is less than 1 or greater than 0. And it's a shrink if that is greater than 1. And the stretch or the shrink factor is really the reciprocal. So if it looks like I'll write it over here. If it looks like the square root of 1/4 x, that A that's being multiplied by my x is less than 1. So that would be a horizontal stretch by a factor of the reciprocal to that A value. So it looks like a 1/4, but it's a stretch by 4.
So if is a horizontal stretch basically the same thing as a vertical shrink, and the vertical shrink is just the same? I mean, a horizontal shrink just like.
No, not always. So again, I want to we really focus on vertical stretches and shrinks. So I really need you to no vertical stretches and shrinks. Horizontal stretches and shrinks, be aware, because you could see a number underneath, but I don't often ask you to graph those. But it is going to be similar to the vertical stretch, but because you're really shrinking the x, not the y's, it isn't always the same thing. So it really depends on the function. It depends on your other transformations. Just visually, when you look at it, a vertical stretch is going to look sort of like the same thing as a horizontal shrink, right? The graph has nowhere to go but up. If if I stretch it, and then if I shrink it horizontally, it's like growing, but it's not necessarily always having the same points. Okay, and then remember in this one, if you had a -8, it would be a reflection in the y-axis. So the last thing, and this goes back to the question that Delaney asked about, these are generally going to be the forms that I give you for square root and cube root graphs. So like that question that Maddie is asking about, notice that the A I'm putting here is really on the outside. Okay. So we're going to focus more on vertical stretches and shrinks, okay, for both of those. And then you'll know it's an H because it will be trapped under the radical. See, the x minus h is under the square root, or the x minus h is under the cube root. So that makes it an H. And anything that's added or subtracted outside of the radical, that's automatically a K. Okay, anything multiplied outside the radical, that's an A. And so your domain is going to change for square root. It's going to be x's that are greater than or equal to h if you move it right. And it's going to be y's that are greater than or equal to k if you move it up or down. So like in the parent graph, because we didn't have any h's or k's, they were both zeros. Okay. But for different square root functions, that starting point that was at 0, 0, that's going to move around the coordinate plane, and that's going to be our new starting point for domain and range. H always goes with the domain, and range always goes with the K. But this one I love because remember we talked about the cube root, all real numbers all the times. If it's a cube root, I don't have to guess domain and range at all. I know it's going to be all real numbers. You can know those things, like for the square root graph, you can like learn x greater than or equal to h, y greater than or equal to k as a pattern. Or like really, truly, you can graph your shapes and look at your graph and decide your domain and range, right? So you pick whatever is best for you. Is it easier for you to do domain based on your picture, or is it easier for you to do it based off of it goes bigger than h? Okay, let's see some examples that you're going to be practicing in your homework. Directions up here at the top. We're going to describe the parent graphs, the transformations from the parent graphs. Then we're going to graph it. And then we're going to do the domain and the range. So y equals the square root of x minus 3. Tell your pod members what you think the transformations are for y equals square root x minus 3. Is that an A, H, or K? That's an H because it's under the square root. X minus H actually moves it right 3. Remember, H looks like the opposite. That's the only change from the parent graph. Okay. So in my head, here's my thought bubble, right? In my head, I'm thinking about 0, 0, 1, 1, and 4, 2, right? My parent graph. And I'm just going to slide all those points right through. So that's going to be at 3, 0, 4, 1, and add 3 to 4, so 7, 2. Ta-da. Remember, think about that mental snapshot we take about the parent graph. It is the same shape. Just slide it over on the graph. Don't create a brand new shape. You know what it's going to look like every time. Domain, x's that are greater than or equal to 3. 3 is the first time x works and gives us an answer. So greater than or equal to 3. Range, y is greater than or equal to 0. You're starting at y equals 0 down here on the x-axis, and you're going up. That's your h, and that's your k. You went right 3, so your h is 3. You went up or down nothing, so k must have been 0. Okay, let's do a cube root. Oh, wait, this is a stretched out. Good. Let's do one square root that has a stretch, and then we'll do a cube root. And then you'll get some time to work on your homework. Okay, tell your pod members what the transformations are here. I'm going to be eavesdropping.
So you go left 5 and down. Well, isn't it? Oh, it's. It would be up 5.
I hear up 5. Why is it not left 5?
Oh, it's not under the radical.
It's not under the radical, right? It's a k now. So that's up 5. I heard reflection. What makes you say reflection? There has a negative out front, and that's actually a reflection in the x-axis. And then the 2, the absolute value of negative 2 is 2. That's a vertical stretch of 2. So here's what I think about in my head for this one. Okay, normally the square root is that like little hill going up, right? If there's a reflection in the x-axis, now my hill is like a little dip, right? A little valley. So I think about the points. They're going to change. They're going to be 0, 0. This one's going to be positive 1, negative 1. So I go 1 to the right, 1 down. And then this one is going to be 4 and negative 2. Go 4 to the right and negative 2. Because I'm reflecting it in the x-axis, so all the y's turn negative. So the parent graph has been flipped. Now I'm going to move all those points up 5. Okay. And I'm going to stretch. Okay. So this one, when I vertically stretch it, its y value is 0. 0 times 2 is 0, so I just have to move it up 5. 1, 2, 3, 4, 5. All right. This y value, remember you're stretching it vertically, so you're stretching the y. We did this back with parabolas and v shapes, right? So this y value is negative 1, but we're going to stretch it by 2, so it's really going to be negative 2, and then I have to move it up 5.
There is a white Ford Expedition license plate WAW 720 that needs to be moved immediately. It is on the north side of the building. Again, there is a Ford Expedition license plate WAW 720 that needs to be moved immediately. Thank you.
Okay, so I had 0, I had 1, negative 1, and then I just stretched it to be negative 2, right? And now I got to move it up 5. So now I'm going to be at 1, 3. Notice that from here to here, instead of just going down 1, I'm going down 2. Okay? Because like it normally would be down 1, right 1. So now I'm going down 2, right 1. Because I've stretched it. Okay? I can do the same thing for this point, 4, negative 2. Let's stretch it first. The negative 2 is the y, so we're going to stretch it by 2, so it would be negative 4. Negative 2 times 2 would be negative 4. And then I have to, so like I would be going right 4, down 4. And then I have to move that up 5. So I'm going to be at right 4, up 1. Oh. Right 4, up 1. Okay, right here. And think about it like this. Like, don't you normally go down 2, right 4? Okay, so I'm going to go down double that from this point. I'm going to go down 4 and right 4, and there I am. Okay. So there's like a couple of different ways that you can do that. But notice the dip is a lot more. It's being stretched, so it goes lower, okay, by 2. I took all these y values, 0, negative 1, negative 2. I stretched them by negative 2, or sorry, I stretched them by 2. And then I just added the 5 back on. So you can do the stretch and then your y's, your up downs. Domain, x greater than or equal to 0. That's your h. There was no right or left. Range is y's. What's going to change about this one? Less than or equal to 5. Thank you. Okay, it's all under the 5, right? Sitting below it. Okay, so yeah, the stretch is probably going to be the part. I see a lot of like looks like. I don't know what you're doing, right? Like the stretch is going to be the thing that we probably need the most practice with. It's the same thing that we did back in chapter 2. Okay, so like this stretch never goes away. It's going to come back to us in another chapter. So like you got to at some point like know your parent graphs and be able to stretch them.
I don't understand if it was like a reflection when the negative would have to be below the x-axis.
You really reflect the parent graph. Like you reflect the parent graph first. So like if you're thinking about graphing, see how this says plus 5 in the function? It is up 5. So in order for you to get that to look like up 5, the reflection happens right away. So do you see my red picture compared to my blue one right over here? This parent graph has been reflected. And now I'm taking this parent graph, I'm stretching it, so it goes lower, and then I'm moving all those points up 5. Yeah.
So there's like a
You should do reflections and stretches first before you like move up and down, yeah. But like your picture, Jayla, should match this plus 5, which is up 5. So it shouldn't be down 5. Okay, one more I want to do is just a cube root, and I'm going to give you your assignment. So let's do the one over here on the left. The cube root of x plus 2 minus 4. Tell your pod members your transformations. Okay, excellent. We're good at naming transformations, because I listened. We're going left 2, because that's under the cube root. We're going down 4, because that's outside the cube root. Okay. So remember your cube root graph, okay, what I'm thinking about in my head. Okay, I have 0, 0. I have 1, 1. I have like 8, 2 over here. And then I have negative 1, negative 1. And negative 8, negative 2. So like essentially those are the points that I'm shifting left 2, down 4. So I'm going to start with this middle one, 0, 0. Okay, that's where that weird bend happens. Left 2, down 4. Because I have no reflection or no stretch or shrink, I can also use like how I would normally get to my next point and just move to get to my next point. Don't I normally go like up 1 over 1? So from this point, let's go up 1 over 1. Or think about taking 1, 1 and going left 2 and down 4. We land at 1, negative 3 either way. And I can do the same thing in the other direction. Go down 1, left 1. Down 1, left 1. Or I can take negative 1, negative 1. And I can shift it left 2 and down 4. And I get to negative 3, negative 5 either way. If you want to move the 8, 2 point, you can. Okay, you're going left 2, so you're going to be at 6. You're going down 4, so you're going to be at negative 2. So if you want to plot a point at 6, negative 2, you can. But I'm also okay if you just kind of like sketch what you think that shape is looking like. Like it's that weird S shape. Okay, stretched out S. And this one, domain would be all real numbers and range would be all real numbers. The arrows are going left and right. One is going up, one is going down. So we're hitting all the numbers. If I had had like a vertical stretch there, then instead of going like just up 1 over 1, I would go like up 3 if I was stretching by 3. And then over 1. Okay, just as an FYI, number 3 is a weird graph. I pulled it without realizing that it was actually a 4th root, so just pretend it's a square root graph. Because you won't find like a stretch or shrink that works, so just pretend it's a square root. It only has horizontal or vertical transformations. Number 3. If you hate number 3 because it's messing you up, cross it off. Okay, that was my bad. I shouldn't have put that one on. Are you going like these right there?
Yeah.
So then 1, 1 is right there.
It's I just
Yeah, and then like a 8, like 4, 1.5. It looks like you're going 1.54. 1.4. That'd be 1.5. Like this should be more like this. It's like side. Your graphic to me looks like the inverse, which isn't cubic. So just like.
do you have white out?
And that's tough. That one, that S shape, people have a hard time.
My brain on math is like, and there's people who like, one goes in for a high five, the other goes in for a fist bump, and then they stop, and then they are like, wait, what's that?
If you ask me tomorrow, I might have white out. But I just want you to know, like when you're graphing
It's
on
like,
your
okay, 2
homework,
plus 2
it
equals
should look
4,
more
right?
like
And then the guy's
this
like, yeah, and it's like, okay, but what about the
across,
graph?
not
Oh,
like this,
no.
or like this, up and down.
I want to retake that test.
Okay.
I need to get the test.
Yeah.
to make corrections.
Yeah. Let me check your homework. You had one missing assignment.
I showed it to you. That
Okay. I'm just gonna ask you again to show it to me tomorrow, okay? I didn't mark it. I probably was too busy if you showed it to me on test day. So you know which one it is. You're just gonna show it to me tomorrow.
Yeah.
Did you turn in the folder?
yeah.
Did you have your name on it? And do you have a plan for when you would like to take it?
Wait, maybe I'll just ask us for instead of.
Hopefully by Tuesday before you go on that long break.
Yeah.
Yeah.
Yeah, that's awesome. Oh, yeah.
me about? Do you have your homework bill? Okay, I will check that tomorrow, so just remember that like has to be true. And when are you planning to take it? You might have to do it like Monday and Tuesday. I don't remember if your homework was, I know you did your homework, I remember you showing me all of it, but I don't know if it was you. I don't know. Let's focus on the test. How about that? That's a lot. What hour is your study hall? Let me see how everything goes today. And then that works out against my so let me know. I'm just
Yeah, I mean,